Okay, so we got some questions, actually a couple today in different places, some on Twitter, some in Slack, essentially about how to include Swift code into your Kotlin native code, right? And I think most people are referring to like, okay, how do I import like a Swift library into Kotlin native code? And that actually is difficult or not possible depending on the situation. So if you have a pure Swift thing that is not Objective-C compatible, you can't actually run Kotlin native's C interop against that. You would need to have Swift code that is Objective-C compatible, and then you could run Kotlin native C interop against that to import it into your Kotlin. But in a lot of cases, I really try to avoid using C interop anyway, partially because the configuration is, I would say, unpleasant, and often because you don't really need to have access to the entire library. It's usually the case that you just need to access a couple of things or just have some input into your Swift code, right? So as an example, we did a Firebase Firestore implementation of a Kotlin library, mostly as an example. And in that case, you're accessing most of the library. You need to have the interop. But in a lot of cases, we're doing things like analytics where you're really only calling one function that's in a much larger SDK. And it's a lot easier to simply pass in some code from Swift into your Kotlin. So that's really what we're going to talk about here. And primarily, you can do that by declaring an interface in Kotlin or by defining a function type in Kotlin, and then you implement either of those from Swift on application startup. And frankly, I kind of put them in the same bucket. And you just have to think of a function type as essentially an interface with a single function definition, and it's not named. I mean, that's really it. They really serve the same purpose. So very quickly, I'll describe how to do that. And not all parts of this are best practice, so I'll let you know which ones aren't. But essentially, I'm going to define in our common code, which is here in common, a variable that's going to have a function type, and we're going to define that in our Swift code. And so we'll call it my function, and the type is going to be, it's going to take a string, and it's going to return nothing. So now we've defined that type in our common code as a variable, and we're going to have to push that in from the outside. Is this the best place to put it and the best way to do it? Probably not, but this is what we're going to do today. And there are implications in Kotlin native's concurrency and memory system about why you might not want to put it here. You can't call this from a background thread, essentially, but we're not going to worry about that right now. So that's the definition of the function we want to call. In Swift, we're now going to define how we're calling that function. So we'll go back, and in app delegate on app startup, we're going to provide that implementation and make sure we do it before anybody has a chance to get there and cause a problem with our late init, right? So my function is equal to, this is like these slightly different definition worlds kind of blow up my thought process here. So void, and then in, we'll do print. We're just going to print this out, right? Hey, oops. Okay, that's it. And then we're doing this init coin thing. So back in Kotlin world, I'm just going to call this function from init coin because it's just a convenient place to put it. Again, it's probably not where you would actually call it, but. So my function, calling from Kotlin. So and then back in our thing, do a clean build. There was a CocoaPods integration issue that required clean builds every time. We've since fixed that, but my local build doesn't have that new fix. So and you can see the output already because I had already done the test. So anyway, yeah, there you go, calling from Kotlin. So essentially the summary is you don't necessarily have to do C interop on a whole SDK that's coming from Swift. You can essentially pass in implementations from Swift, and it's generally a lot easier and more flexible if you don't need to do everything. So there you go.